It's log, it's log, it's big, it's heavy, it's wood. It's log, it's log, it's better than bad, it's good. Everyone wants a log. Hello there. Now, that was the infamous log song from the Ren and Stimpy show. And that's our topic for today. All right, logs, logarithms is what it's short for. All right, now today is pretty much an introduction to logs. I'm going to lay out the framework, talk about what it means. Now, after spring break, when we get back, we're really going to take this to the next level. So today, just kind of bear with me, understand it, know what's going on, learn the basics, and then we'll really talk about what it means later on. Now, the first thing is log is just a notation. So let's say I have this. All right, what we pronounce that is log base 10. All right, so when I say log base 10, this is how we write it, referring to the base down here. All right, so say this to yourself. What would this be called? Log base 2. All right, and then we have ln. All right, this is called our natural log, and our natural log has base e. So it's really log base e, but we write it just like this because e is so special. All right, so log base 10, log base 2, ln, we say natural log. All right, so that's kind of the log lingo. Now, a lot of times we're going to have problems written in this form. Okay, log base b times y equals x. Now, what this translates to is this problem, b to the x equals y. All right, now, so we're just kind of changing the way it looks. It's just a notation, kind of like f of x, okay, equals 2x plus 3. F of x is just a notation. Y equals 2x plus 3. All right, same idea. Okay, this is just a notation, kind of like an f of x notation, a function notation for all this noise. All right, now, the end plan is eventually you're going to get something like this. 2 to the x equals, we know if we put 8, we know it would be 3. However, what if 2 to the x equals 9? So what logs allow us to do is solve for this exponent. All right, we could take the x root of both sides, but that's not going to help us because we still have a variable in our problem. So again, today is just to expose you to the idea of logs. The end result is once you know everything about logs, you're going to be able to solve an equation like that. All right, so let's practice some of these. So log base 2 times 32 equals 5. All right, so what this looks like is your base raised to your exponent, which is on the other side of the equal sign, equals 32. All right, one more. Log base 1/2 times 2 equals -1. All right, so I get 1/2, because that's my base, to the negative first power equals 2. All right, now what if I gave you this? 5 to the 0 power, whoa, equals 1. We all know that's true, but how would you write it with the log? All right, we would have log, my base is my number, log base 5, my exponent is on this side of the equal sign, so 0 would go, my exponent is on this side of the equal sign, and then 1 would go there. All right, so now that you know what it represents, that's our general formula, let's evaluate with it. So evaluate, and we're not going to use a calculator here. Whoa. Okay, so let's say I have log base 5, call this number 1 now. Log base 5 times 125 equals x. So I have 5 raised to the x power equals 125. So what 5 to what power equals this? Well, last chapter we did a lot with changing the bases, and we know 5 to the third is 125, so x is 3. Okay, again, all the problems now I'm going to give you are trivial. We're going to know how to do it. All right, log base 8 to the 1. Evaluate. All right, well, we have 8 to the what power equals 1, right? Because we don't know what's back here. So that's what we want to know. What does it equal? Well, 8 to the x power equals 1, so we know x has to be 0. All right, one more. Log base 4 to the 1/2. What does that equal? So I have 4, my base, to the exponent x equal to 1/2. Right, well, in order for that to happen, x would have to be negative 1/2 because 4 to the 1/2 bumped downstairs. All right, now you'll also be asked to do this with a calculator. So with a calculator. So let's talk about that. This is number 4. We're going to go natural log of 5, log of 8, and log of square root of 2. Number 5, number 6. All right, so take out your calculators. First one I have is natural log of 5. So natural log of 5, notice how you have your LM button here next to your 4, our E button. Okay, so ln of 5 equals, we get 1.609. Log of 8, our log is right here next to our 7. So log of 8 would give me 0.903. All right, and then our last example is log of root 2. So log of second root 2. And I'm in double parentheses in case we had to multiply by something else. And I get 0.151. All right, so those are where the buttons are located on your calculator. So we got 1.609 here. We got 0.903 and 0.151. All right, so that's what the pieces of log represent. That's how we evaluate them, and that's how we put in our calculator. Now, for one of the most important pieces, inverses. Okay, now today you're going to be like, why is he making us do this? It doesn't make any sense. And I'm just going to ask that you bear with me, that you understand how to do this, because again, when we get back from spring break in 2 days, we're really going to take off with this. All right, and you need this skill I'm about to teach you in order to be there, in order to do well there. So when we talk about inverses, think of if I had x plus 2 minus 2. Okay, we know plus and minus, addition and subtraction, are inverses. So this would leave me with just x, because the 2 and the negative 2 would cross each other out. Same would go for if I had x times 2 divided by 2. We would just be left with x. Multiplication and division are inverses, and they cross each other out. All right, so logs are the inverses of exponents. So let's say we had our general form, log base b, all right, and then we have b to the x times b to the x equals x. Now, what this log base b allows us to do is take out those, okay, because they are inverses of one another. Similar to this, these are inverses of one another. Again, I know this is tough to grasp because we don't really have a purpose for it yet, but I just want you to go with it for now. Trust me, it'll make sense in like 2 or 3 days after spring break. All right, so then we're left with just x. So if we had that, log base b and b cancel each other out, just like positive 2 and negative 2 do. 2 divided by 2 do. All right, so this would equal x. So let's say I had, and it can go the other way, b raised to log base b times x. All right, my b and my log base b are inverses of one another, so I'm left with just x. All right, so whether you have it either way, that's the inverse, and it allows you to be left with just x. So in a sense, they cancel each other out. So 10 raised to the log base 10 times 2. And then I'm going to go log base 3 times 3 to the 5th power. All right, 10 raised to, there, those are inverses of one another. They cancel out. You're left with 2. Over here, same idea. All right, log base 3 times 3, your base is 3, your exponent is 5, you're left with your exponent. All right. We doing okay with this? Let's try this one. 8 raised to log base 8 to the 3x. So go ahead and tell me what you're left with. These are gone, so I'm left with 3x. Excuse me. All right, let's try a more difficult one. Excuse me. Log base 3 times 9 squared. All right, so in order for this to cancel each other out, we need this to be base 3. All right, we need that to be to the 3rd power. So 9 to the 3rd power we know is 3 squared, and we still got another squared on top of that squared, right? So I'm going to leave it like this. I know it looks funny, but just for the sake of understanding. And we have log base 3. So this is 2 squared. So really I have log base 3 times 3 to the 4th. Then log base 3, my base 3 are inverses, so they cancel each other out, and I'm just left with 4. All right. So, again, I know it's a little, why is he doing this? This doesn't make any sense. He's just crossing stuff out. Well, it's just to get you to understand what do the inverses look like and what does it mean. Then we'll put it into context after spring break, really put a purpose to this, and go from there. All right, thanks. Enjoy your spring break.